discuss what the weighted residual method is. Weighted residual method where we find that residue or the error, we find the residue or the error, and we also find a weight function and we operate the weight functions on the R, or basically you can say we multiply weight with that error, and we are make the error zero in an average sense over the entire domain. Okay, we are making the error zero in average sense over the entire domain. Okay, now how we choose the weight function, depending on that we have various method, and very four popular method is that Galerkin method, least square method, point collocation method, and the subdomain method. Okay, so how we used to choose the weight function, depending on that we have various weighted residual method. So in the weight in the Galerkin method, what we observe that weight function is same as our trial function. Okay, in the least square method, what we observe that we try to minimize the square of the error, and there we assume weight function as a basically derivative of the error with respect to some coefficient. So how we get that, that is already have discussed. Okay, now we'll discuss our point collocation method. Okay, so here you just see we have point collocation method, means basically we are trying to make the error zero in some point. Okay, so collocation basic means that positioning close together, okay, or side by side. Basically what we are doing, we are basically uh, making error zero in some point. Okay, so that is basically our point collocation method. So in the point collocation method we use a weight functions, and weight function we consider as a direct delta function. Weight function we consider the direct delta function. Direct delta function is such that that value of that direct delta function here weight is equal to 1 when we choose some point collocation point where x is equal to xi, and the rest of the point it is 0. Okay, so here our weighted residual will be 0 in certain point, certain collocation point. Okay, so this is basically known as point collocation method. Here we will see how we basically solve a problem using point collocation method. So we have simply supported beam, and we know that for the simply supported beam y is equal to 0 at x is equal to 0, and again y is equal to 0 at x is equal to L. And for our simple supported beam, our actual solution basically look like this. We will try to find what is our approximate solution, and we also know that ei dy dx2, that is equal to moment, and here at the end moment is applied. So our equation for the force or moment equations will be ei dy dx2 minus m 0 is equal to 0. Okay, so what we are doing, we are basically assuming a trial function. Okay, so once we assume a trial function, then instead of y, if we assume a trial function u, then again this value will not be 0, will have some sort of error. Okay, so here you can write in this way, you can write that ei d2u dx2 minus m0, that is equal to 0. Okay, now what we'll do, we already assume a trial functions, and we'll put the value here. We take the double derivative and we'll put the value here, and that value basically will not be 0, but we'll try to make it 0 forcefully. Okay, in some selected point. Okay, that is our point collocation method. So here we'll try to find the error, that is will be our error. Okay, so now thing is that at which point you should choose. So now here question is that how many point you should choose. So here this how many point we should choose, that depend on how many number of unknown variable you have. For this problem we have one unknown variable, that is our a. Okay, so we'll choose one point of collocation. Okay, 1 point. Okay, if we have number of unknown parameters in the trial function, if in the trial function or approximate function, if you have more number of trial function, then we have to choose more number of collocation point, and you have to make the error 0 in that point. Okay, for example here we choose that x is equal to L by 2. Since nothing is given there, we have chosen x is equal to L by 2, that is one particular point, because we have one unknown, that is our a. And what we'll do, we'll find the error and we'll basically multiply, you try to find the error and we'll try to make the error 0 in that selected point. Now what is that error? Error here basically what you have to do, you have to find x is equal to L by 2. Put x is equal to L by 2. Again, already you have discussed that point collocation method, our weight function is a direct delta function. That means at direct delta function means weight at x is equal to L by 2, that value will be 1. Okay, so here again we are choosing weight function as a 1, and we are basically if you multiply like this, okay, W into R at x by 2, that we are making at 0. Okay, so what we'll do, we'll put the value of x is equal to L by 2 and W is equal to 1. So basically error here will be 0. Now if you solve it, we get our value A, that value of A is equal to m0 L square by I pi square. Okay, so if we put the value of A in our trial solution, we get this is our trial solution or approximate solution. Again, we know our actual solution is like this. Okay, now if you want to see what the error is there, so what you do, you have to plot it, then only you will get the sense how much error is coming. So this is our actual solution and this is our solution obtained from point of collocation method. Here we assume some value so that we can get some numerical data to plot it. So this is basically our point of collocation method. Okay, so point collocation method is that method where we make the error 0 in some pre-selected point, and here we assume a weight function as a direct delta functions. Basically we assume weight is equal to 1 in the selected point and rest of the point weight is 0. So basically we are basically obtaining W into R is equal to 0 at some selected point, and we obtain our unknown parameter and we get that our solution. The number of collocation point depend on the number of unknown parameter we have in our trial solution. So here trial solution we assume as a trigonometric solution. Okay, in the next problem we'll try to see if you obtain a trial solution as a polynomial. For example, our u is equal to a plus bx plus cx square. Okay, then how we can obtain our approximate solution using point collocation method. Here you can see we have 3 unknown. Okay, so now you have to see how you can deal with 3 unknown to get our approximate solution. Okay, thank you. I hope you get some idea. Thank you.